Okay, welcome back. I want to knock out find last and see we did find index. I want to do find last and find last index and last index of because I think they're also closely related to the last functions we've looked at. But before I get into that, I was watching the video I just recorded, the one right before this. And I got tripped up about 8 minutes in there, and I didn't know what I was doing, and I almost tricked myself into thinking I knew what I did, but it was really I just meant to be using uh, find index, and when I decided to partially apply it, I used index of. And the reason I'm mentioning that, you probably saw that as soon as I did it, or as I was copying and pasting things around. But I think it's interesting to know why, if I run this, I get -1, I don't get an error. And this is one of those funny things about JavaScript, where JavaScript is too helpful sometimes. I would have preferred it to throw an error, um, and say, because the problem is the argument that I was passing. If I'm using index of, wow, look at that signature. It asks for an X of any type, but not a function. And I'm passing a function. But in JavaScript, a function is a value. It's a value of any type. It's type A, any, it's but what it's looking for is an item, and actually I didn't pass the X's to it. So I should get the same result, but this is correct now. What did I do? Index of five, find index of five. Sorry, just need to pass data to it. Yeah, so I get -1. And the question is why? And the reason is because it's looking in this list of data for a value, which is a function called is5, or a variable called is5, just something with the name of is5. And of course, that's not in there. But if a function is just a value, you can put a function in a list along with numbers because JavaScript just does not care, when it comes to arrays. And if I'm right, I haven't checked this out, but if I am, I should get 0, 1, 2, 3, 4 as the answer, but I don't. So cannot access, order operate, or yeah, order here matters. So run that again, and I get 4 because now it can find this value. So, we hear that a lot in about JavaScript, that in JavaScript, functions are first class citizens, meaning that functions are just values like any other simple value, like a three or a true or a letter L. Um, so, you may have that sometime. You may have an array of functions and you want to know if or where in that array the function is located. And, you want the exist or you want the index. Um, so anyway, I just wanted to go through that real quick and follow up without re-recording because part of this is I don't want this to be well structured. I don't want to. I'm really. This is like a stream of consciousness for me. I'm explaining this to you as a way to explain this to myself in order to understand something better. Because we all know we can read something and play with it and feel like we understand it. But then when we try to explain it, it becomes clear that our level of understanding is not where we thought it was. It's basically like running a test on ourselves. Um, and I'm mixing first person and third person as I'm speaking. But again, I just want this to be raw. And that's great because that's what it is. So, anyway, let me clear that and let's go in here and pick back up with find last. So, let's compare find last, the type here, to find, right? So, we got a predicate takes an A, returns a Boolean. A list of the thing that we pass is the first argument to the predicate function. So if A is a string, this should be a string. Um, of course, I had that list of numbers and a function, and those are both not the same types. So there's a little wiggle room here, and I'm not sure what it is, but I could guess that it just matters that, we're calling this function on each individual element in the list or in our array. So at that point, as long as the A at the time we're invoking it is the same as the um, item in the list, then that still counts as both being A's, and then it returns an A or undefined. Um, so anyway, the point is a predicate function followed by a list. Those are inputs. And here a predicate function followed by a list. So it's the exact same signature. So all we're doing is looking from the end. So we could do that with find. Get rid of my x's. 5. So I could say log r.find. Inline will say x. So this one takes the function. I'm going to say x. What do we want to find? 5. So if x equals the number 5, and then call it on our data. So let's just do that much, make sure I got that right. Or sorry, I wasn't fine to find index. That's why I'm glad I tested it. Yeah, so it's the 4th index in our array. Um, but I mean, we could use a pipe, right? I mean, in my mind, the whole point of functional programming is to be able to put functions in pipes. That's my goal, kind of simply stated. Uh, and so we could do, I'm sure, yeah, there's a reverse function. So we could reverse the list first, and then we could do all this business. Oh, stuck here. There we go. Let's see. Let's run that, and we get. Okay. Let's see. Reverse. Oh, reverse takes a string, but here we got numbers. 1, 2, 3, 3, 2, 1. I'm passing an array. Oh, no, I'm not. I need to call it with the data. And we got another error. Call, goodness. Okay. So what I'm trying to do is I'm trying to pass in the list, reverse the list, and then find the index. Oh, because now I don't need to pass it here. Yeah, and we get 0, and that's correct because our list is reversed. So this 5 now is here. So we've got, you know, 5, 4, 3, 2, 1, an array that looks like that after we reverse it. So this find last is going to do the same thing without having to reverse it. So we can have a pipe with this one function. So I'll just leave it. And we'll change this to find last. Of course, these aren't exactly equivalent because I've kind of mixed up the index of the find index versus the actual element, but still holds true. But now I'll go back to what I originally intended, which is find last. And we get undefined because find last takes an X. Let's get rid of the pipe here and simplify things. All right, so I should get the same result, undefined for some reason. Okay, so we have this and there's semicolons. Yeah, it had something to do with putting that list in. Not let's prove that. If I put a semicolon in here and run it, yeah, I get 5. So that's one of those things where you can get yourself into trouble by trying to not use semicolons, but less is more for me. I'm a minimalist. So anyway, that's how that works. Find last, we're taking the lists, we're passing in a predicate function that returns true for the element that we're looking for. And then we pass the x's. And of course, we could do this all at once and run that and get the same thing. And, in the last video, I was talking about how I don't mind doing this. When you do this from the start, when you're calling a function and then you get the result of that function and then you apply that function to the next thing. So you're using like one argument in one set of parentheses. Um, as you're refactoring, you can just go in and grab this without having to rearrange the commas and the parentheses and the arguments. So I can just go const fn equals all that, and then apply the function, and I get the same answer. So that's one reason why I think it's actually a little bit more convenient to not call everything at once. And it also kind of lets you know more clearly that these functions are curried. And so you can see when, I don't know, you can see when you're trying to call a function in, I guess, more than one step, but all in one line without, so you're partially applying a function, but you can still partially apply everything and call it all together, like I just did with multiple sets of parentheses at the end of the function name. Um, yeah, so that's just another aside. And the reason we can do this is because with functional programming, when I say fn is set to this stuff over here, I'm also saying they're exactly equal. And there's the term referential transparency, which for some reason I just love the way that phrase sounds. Referential transparency. It just sounds cool. Um, but it means that I can, this function is exactly this. So I can replace these things without having to think about it. I can break things apart and make them smaller and have less to look at and less to concern myself about and less to test, one time. Um, so I find myself breaking these things apart quite a bit. Um, just as far as how it looks, when I first glance at the function, if there's too much nesting, if there's too many parentheses or nested parentheses, it just the mental load to try to figure this stuff out becomes hard. But if you just break them apart into little pieces, you can understand a little better, or at least I do. And then you can always put them back together. So sometimes you can go overboard and break things apart so much. And then you have what I guess people call indirection, where you have to move around in different places in your code. And then you have issues where you're trying to use something that hasn't been defined yet. So you have to move the code up, maybe off screen, and then you're doing a lot of scrolling, so you can go too far. Um, but it's up to you, it's how you feel. So that's find last. And then we have find last index. And so this is going to be basically the same type signature as find index, right? So a predicate, a list, and it returns a number. Here you got a predicate, a list, and it returns a number. So it's just basically we're saying we don't want the value back if it exists. We want the location of the value by index from the array. So we'll just find last index and we'll just use the same one. And yeah, so we can find the index of the value that equals 5. And So what should we get? 4? If I run it and we get a 4. Yeah. So, same thing. It's just searching from the right. I'm going to actually just dig in real quick. I don't know if this is going to be too complicated, but I wondered if they actually reverse the list and use find. Let's do find last index. No, because they're using a while loop, which is probably much more performant. Um, but, you know, if I was worried about, I'm never going to be worried about performance working with a list of 5 values. I mean, that's ridiculous. In fact, I think people are too worried about performance. And of course, functional programming, you often give up a little performance for clarity or clarity of thought. And of course, there's compilers and optimizations with interpreters. So you never really want to assume that you're getting less performance by using, array methods like map, reduce, filter, or find index, find last index. You know, don't worry about performance unless it's a problem. Um, and then what else? We wanted last index of find index. Yeah, this both have transduce, but let's just look at last index. So this is the same signature as index of. It's just doing the same thing. So let's just reuse this. But of course, we don't want to make the same mistake I made before. Now, see here, we actually get an error. R.last index is not a function. Last index of. Yeah. So yeah, we get the -1 because of course it is looking for this function. Now I wonder if we could just put this function in here as an anonymous function. I mean, I think that should work, and then we get the result would be 5. But no, we get a -1. It may be a syntax thing where we need to wrap it in parentheses so it becomes an expression. But no, we still get -1. So it's still not finding the last index of this. Yeah, I think it just doesn't work that way. But it did. Now we could name it. Let me just prove my theory here, one way or the other. Um, call that is 5. It's x equals 5. And then if we put the name in there, uh, well, that's still not going to work because, yeah, that's not the same thing. But if we look for is 5, now we get it. So that's something I learned. I mean, it's an anonymous. I guess it's anonymous for a reason. It just works where you're using it. It's not named. So always question yourself when you're using an anonymous function. They can. I don't use the debugger a lot in the browser console, but for people that do, it can be kind of a nightmare debugging anonymous functions, especially if you have like 10 anonymous functions. So sometimes maybe it's just better to name it. Yeah. So that's this. Well, let's see, where are we going next? Let's find line. Okay, so then we move into flatten. So we get out of this finding stuff. Maybe this will be a little bit more interesting. And yeah, so again, thanks for spending your time with me, and tell a friend.